Good day, guys. I hope you're all doing so well. So, namhlanje we're going to deal with theorem number 3, and this one is not examinable because it is too easy, and it is similar to, it's the same as theorem number 2, but I'll just show you how it is similar to or the same with theorem number 2. So, theorem 3 states that the angle subtended by a diameter at the circumference of a circle is right angle, meaning you have an angle there that is made by a diameter. Basically, diameter here it is A, B, and here from one point to the other is a diameter. It is also a chord, which means this chord or a diameter, even it is even in an arc AB, it makes an angle at the circumference, this angle, and this angle that it makes, it is equal to 90 degrees, or it is a right angle triangle. It's a right angled, yes, here. And even if it's the diameter, you have center, perhaps with, let me just say center O. That means angle here, or angle O, it is angle on a straight line, so it is equals to 180 degrees. So you must remember this kind of arrangement that says a good angle at center, it is on a straight line AB, so it is equal to 180 degrees. So it can be O1 or O2. You can have two angles at the center. You can say O1, there is O1 and O2 at the center. Those two angles, they equate to, or they sum up to 180 degrees because they're on a straight line. I hope you understand. So theorem number 3 is that it's if you have an angle, or if you have a diameter, that diameter will make an angle equated to 90 degree angle. And this theorem is the same as theorem number 2, because theorem number 2 it says that if you have an angle at center, that angle is twice the angle at circumference. So it's similar to theorem number 2. So the reason you can use for this theorem, if you say you have a diameter and you must prove here is 90 degrees. If you say that angle C is equal to 90 degrees, they must say that because of angle in same circle. Basically, in a question they can give you this type of arrangement whereby they will say we have a diameter J, and they will not tell you angle C is equal to 90 degrees. So if we have a diameter like this, in this way, you will then assume that angle C is equal to 90 degrees because of what? Because it is an angle in semicircle. It is an angle in half of the circle, subtended by the half of the circle or diameter. I hope you understand. This theorem, it is not examinable because it's too easy. I think so, yes. Then let us go to theorem 3b. Theorem 3b, which is basically the opposite or the converse, the opposite of theorem number 3a. So this one, in this case, they give you a diameter. They give you an angle with 90 degrees. So they don't tell you this is a diameter AB. They just give you an angle equated to 90 degrees. So it says that if a chord subtends an angle of 90 degrees, this is a chord AB, it subtends an angle 90 degrees, or it makes an angle equal to 90 degrees at the circumference of a circle, then that chord is a diameter of a circle, of the circle. That means if this diameter makes up an angle that's equated to 90 degrees, that means this chord, it is our diameter. So you just assume this chord, it is equal to 90 degrees. It is a diameter if you have an angle, or if it subtends an angle equated to 90 degrees. I hope you understand this theorem, and the reason you could use you will use when they give you a 90 degree angle, and they will say and you assume this chord is a diameter, you say therefore the reason I can use for this such arrangement, you will say that because of chord subtends a 90-degree angle. Chord subtends 90-degree angle. Then you are done. I hope you understand, guys. Let us break some few examples of this theorem. Yes. So we have an example here that is so. This is just a typical example. That is so simple and easy and blunt. Yes. So we are given that AB is a diameter. So we are given now. Okay. Let's assume that AB is a diameter, guys. When you talk about diameter, you must remember theorem number 3. So simple. Diameter, it means angle C is equal to 90 degrees. Reason angle in semicircle. So we're given AB is the diameter of the circle, center O. You all know that angle O is angle on a straight line, and angle on a straight line equal to 180 degrees. Angle A is equal to 27. We are given angle A equal to 27. Calculate the size of angle B. So simple, guys. How will you find the size of angle B? Let me just write the given, or those ones that matters, or that could give you marks in the examination. So angle C is equal to 90 degrees using angle in semicircle. Then after that, they will say, and they say that you must calculate the size of angle B. So simple. So you have a triangle inside the circle, and you have two known angles and this one unknown. So you can find angle B by using sum of interior of triangle. So we say that angle A plus angle B plus angle C equals to 180. Reason interior of triangle. Guys, you can just structure your, or can just create that table of statement and reason. It's not a problem. So now I'm just show you how to reason on which statement to write in such activities or in such examples. So what is the value of angle A is 27. What is the value of angle B? It is unknown. What is the value of angle C? Is equal to 90 degrees, equal to 180. Then now, what you need to do, I need to be left with B on one side, the variable or the unknown on one side. So that you can just say, okay, 180 minus 90, then minus 27. You're going to basically transpose those two constants to the right hand side to be left with angle B. So we see that 180 minus 90 minus 27 is equals to 63. I hope so. Yes, 63 angle. I hope you guys understand this example, and in the examination they will mark it so simple. They will just say, okay, they will just give you 2 marks for stating how did you get angle C, and they will just give you the final answer plus 1 mark for your statement and your reasoning. I hope you guys understand this example. Yeah, so let us do the last one. So simple. The last example is so simple. Lemon squeezy, peasy, lemon squeeze, baba. So number 2 says that MPS and T are points on a circle with center O. MPST are just points on a circle. PT is a diameter. PT. So diameter. PT. Where is PT? Here's PT. What do you know about diameter, guys? Remember, I just taught you how do you identify diameter and what are its factors or components of diameter. Diameter is that, okay, this angle here at the circumference is equal to 90 degrees. That's the first thing you must know about diameter. You can see that this diameter subtends an angle equal to 90 degrees, meaning angle M1 plus M2 equal to 90 degrees. That's one thing you must know. And again, what do you know about diameter? According to theorem number 3, it says that, okay, Angle O, it is at the center of the circle. That means it sum up to 180 degrees. This angle is equal to 180 degrees. Then you can just continue the statement. Okay, we can just continue with analyzing the statement in pointing out and demonstrating on the diagram what the statement says on the diagram. And M1 is equal to 53. Here is it. Determine with reasons the size of O2 and M2. O2 and M2. Simple. Let's do it. Yeah? Yes. Guys, let us check here. We have P and S, and P and S are on circumference, a point and circumference. And we can say that, okay, according to theorem number 2, if you have an angle at center here, O1, O1, it has a chord or arc PS. So if you can use your hands, you see that, okay, PS is our arc, and O1, it subtends or it makes up M1, or O1 is equal to twice M1, because these two angles are both subtended by this arc PS. O1 PS subtends M1. Simple. So you just want to say O1 is equal to 2 times M1. According to theorem number 2, reason angle at center equal twice angle at circumference. Then what is the value of O1? It is unknown for now. O1 is equal to 2 times M1, 2 times 53 degrees. Then you just gonna say 2 times 50 degrees is obviously 106, guys. Yes. Then O1 is equal to 106. Then you're done with finding the value of O1. How will you find M2? How will you find M2? Remember, angle M1 plus M2 is equal to 90 degrees. Raising angle in semicircle. Then what is the value of M1? 53. Then how will you find M2? By just substituting where you see M1, you put in 53 and transpose that 53 to the right hand side, and you see that 90 minus 53 is going to be 90 minus 53 is going to be 37. Yeah? I hope so. Then this is the value of M2. How will they mark it? Obviously, we have the final answer, and this is how we now mark it. Then the final answer and statement, and your reasoning, obviously. So 4 marks is there. So guys, I hope you understand this theorem. The next time we'll do theorem number 4. Have a great day, great 11s and great 12s. Enjoy your day and enjoy your metric as you about to write your trial examination. I hope I'm gonna see you in the next video. And if you're not satisfied with the video, or if you're not satisfied with the content, or if you don't understand what I'm trying to bring about to the table, just poke me on the comment section, or just give me suggestions on the comment section. Thank you guys. Enjoy your day. Usually.